So hello guys, we are going to discuss a CSES problem, coin combinations 1. So the problem is we are given n coins and we have a positive integer x and we have to find the number of ways to make the desired sum, right? So by seeing the example test case, we can see that the relative ordering do matter, right? 225 and 252 will be treated as different, and we can take any number of the coins, right? For example, if we are given a 2, we can take as much as we want, right? We can take 4 coins of 2, we can take 5 coins of 2, and so on, right? So we are going to solve this using dynamic programming recursion, right? Okay, so let's solve it, guys. So basically, what is happening over here is that we are just taking a standard input, right? This is the standard input taking, and just we are initializing the DP with value which can never be the answer, right? Just to check, because generally we initialize a value by uh, which can never be an answer, right? So we can be sure if the value is this, then the answer is not calculated, right? Otherwise, it is. So basically we are just making a call to the recursion function. Look, I have x amount of money to be made, then just tell me the number of ways to make it. Okay, so let's see what the function does. So what the function says is basically, if x becomes 0, so it is very much possible that we have come it by a valid path, so we will just return 1. And if x is less than 0, that's not a valid path, right? So we will just return 0, right? Because that's not what we wanted and should not contribute anything to the answer. And then we are checking that if that dp of x is there in a cache or not. If it is there, then please return it, otherwise we will do the computation. So what we are doing in the computation is just we are just initializing the number of ways in which we can make the value x, right? And at any point of time I can take any value, right? I can like literally take any value. So I am just iterating over all the coins, and what I am doing is basically finding the number of ways to make x minus array of I, right? We are just making this thing, right? Like if I can make at the end at the end of making x, I must be taking something, right? So just tell me the number of ways to make this, so this will be our answer for that. If we are taking array of I is the last element to make that x, we will just add it in an answer and just store it in a cache, and we will just return it, right? So this is how our recursion is working. A brief also about also let's talk about the time complexity and the space complexity. Talking about the space complexity first, so we are initializing a dp, right? So it is O of x, right? and and if I talk about time complexity, it is x into n, right? Because there are so if you guys always are confused, so key how we calculate the time complexity of like recursive functions. So generally what happens is like the number of states, right? Number of states, right? Number of steps into the computation which we do per per state, right? Number of states into the the time complexity of the recursive function itself, right? So what is the time complexity of it? It is into n. So it is basically number of states are x into n. So this is our time complexity, right? So generally this is the complexity, because what we can do is we can count the unique number of states and then we can multiply it by the time which we are taking in the recursion itself, right? I hope it is clear. So let's try to submit this problem. So yes guys, our is submitted. Okay guys, our solution is accepted. See you in the next video.